Okay, so VB is negative 20. Why? Because if, frankly, it's actually from the circuit itself, you can see that directly you can see that VB is negative 20. Or if you don't see, so maybe I write down the equation. So this one is your VB. Okay, this is 0 voltage. Okay, so I assume that this one VB minus 0. So the current is flowing from here. So VB minus 0 is equals to negative 20 volts. Or in other words, is VB is negative 20 volts. Okay. So right now, VA. So what is VA? You can see it directly without any calculation. Yeah, actually, you need to be carefully. VA is actually negative 6, not positive 6. It's actually negative 6. Okay, this point here is 0 volt. Okay, because as you can see, this one is also 0 because it is connected through this node. Okay, so this is 0 volt. Okay, so we assume that the current is going from VA to 0. So VA minus 0, so is equals to negative 6. So that's why VA is negative 6. Or if, for example, if I assume that the current is going from 0 voltage to VA, so what happened? Should I get the same answer? Yes, you should get the same answer. Let's look. 0 minus VA is equals to positive 6, right? So right now my VA, negative VA is 6. VA is negative 6. So your VAB is, VA is negative 6. Okay, it's actually VA minus VB. So you just substitute the values. So negative 6 minus your VB is negative 20. So you should get positive 14 volt. So that is your VAB. Okay. Any question? Okay, if there is no question, then we proceed with question B. If Ix is 7 amperes and the flow direction is from node A to node B, calculate the value of the resistor and calculate the value of the current. So actually, as mentioned before, this Microsoft Whiteboard is the new version, but I think it's downgraded. It's downgraded version because in the previous version, I can just cut and paste the pictures and so on. But right now, I cannot cut and paste the pictures. So I need to download it first and then insert these pictures. Okay, so I don't know why. And the sensitivity also is actually much worse compared to the previous version in terms of the dispense sensitivity. Okay, so if Ix is 7 amps, what is the value? So we assume that, so the current right now is direction from here. So meaning that your Ix is V from A to B, okay, over R. So R is VAB over Ix. So your VAB is right now is 14, right? As previously calculated. And your Ix is 7 amps. So directly you can get 2 ohms. What if my direction of Ix, for example, what if my Ix direction is actually here? It's reverse. For example, the question is actually Ix. What is Ix? Okay. So right now, as you can see, the value of the current direction of the Ix is from B to A, meaning that this is VBA. We know that.
So VB minus VA.
Yes, correct. VB minus VA. Correct. Thank you. So VBA is VB minus VA, and it's just a straightforward, which is negative 14. Okay. So if you don't very convincing, so you can write down VB minus VA, which is VB that we have already is actually negative 20, and minus VA is negative 6. So that's why we have negative 14. Okay. So over your resistor is 7 ohm. Sorry, your current 7 ohms. This is R, this is your Ix. Okay, negative 14. And Ix is come from this one, B to A. So this one is 7. So should be Oh, okay,
Doctor, I
okay.
think it will also should be -7 because current direction is also changed, not the voltage
Okay, okay lah.
polarity.
Okay. I think this question is not very suitable. Okay. It's not suitable for me to do this kind of example. It's not suitable. Okay, so please ignore that. Okay, because some of the calculations, or some of the question they have already designed it. Okay, so I think not appropriate for me to reverse the direction and so on. Okay, so and then C, calculate the total power supplied by the circuit. Oh, sorry, we haven't yet calculate the current high here. The current. So right now R is actually what we have previously is 2 ohms. Okay, so right now calculate the current. Okay, so to calculate this current, so what I need to do is to identify the direction of the current. So just assume, okay? You just assume. So for example, I assume the direction of the current is like this. Okay, I think this one. And then this current direction, I think, okay. This current direction is going down. And this direction is going here. Okay. So you need to define first the direction of the current. Do not change the direction of the current. Okay. You need to be consistent. Okay. So right now you can use your basic Ohm's law to calculate all the current. So right now this node is negative 6 volts. This node is negative 20 volt. Okay, this node is 0 voltage. Okay, so I give this one is I1. Okay, Ix. This one is I2. This one is I3, and this one is I. This one is I4. Okay, so from this diagram, from this circuit, you can directly calculate your I1. So I1 is actually from 0 voltage to VB. So 0 minus 20 volt, 5. So this one is 20. So this one 4 amperes. Positive 4 amperes. Meaning that the direction of my assumption of direction is true. It's actually going down. Okay, my assumption is actually true. Okay, so the current is actually going down. Then I need to calculate my Ix is already calculated. Ix is actually 7 amps. Okay, based on this one. And then what else? I2. So I2 is actually flow from, we assume that the current flow from 0 voltage to -6. So 0 minus VA, which is -6 over 3 ohms. So this one will become positive 2 amperes. So that is my I2. Okay. And we know that this KCL here, we have KCL at node A. We have I2 going into equals to Ix plus I3. So from that, we can calculate your I3. So your I3 is I2 minus Ix. Okay, so my I2 has been calculated. So at 2 amperes minus Ix is 7. So my I3 is -5 amperes. So what is mean by -5 amperes? Meaning that the current assumption is actually going up. Okay, going up. But actually the real current is actually going down. Okay, so our assumption is actually in opposite direction. But it's okay. We please just stick to this direction and the value that you obtain. Okay, do not change that. Okay, I just want to remind you that just this one is meaning that the assumption and direction is actually in opposite. Okay, I hope you get that. Please don't change. Okay, please don't change this direction after you have assumed. Please don't change that, because it will be very complicated if you change. Okay, so next is what? So we have already obtained I1, I2 also, and also I3. So Ix, okay. So right now is actually to get your I4. So KCL at node B. Okay, we know that Ix plus I1 is equal to I4. So Ix plus I1 is equal to I4. Okay, so this one is actually equals to Ix is 7 and I1 is 4. Okay? So this is 11 amperes. And finally, the current that the question required is actually I here is equals to, we have at this node, we have I3 plus I is equal to I1. Okay. I think this one KCL at node, I think this one not X. Okay, just put it as a node X. Just name it as a node X. Okay, I1. Is it I1? So I3 plus I is equals to I1. Okay. I3 plus I is equals to I1. Okay, that is where what you call this one, I3. If you change I3 here to positive, the direction and then the direction, so your answer for the I will be totally wrong. Okay, so please stick to the assumption that you have already fixed. Okay. So don't change. So I3 is remain -5. Okay, -5. Don't change to +5. Okay, -5 plus I is equals to I1, and your I is equals to I1 plus 5, and your I1 we have already calculated is 4. So 4 plus 5, so your answer is 9 amperes. Okay. Okay. The last question, calculate the total power supplied by the circuit. So you have two voltage source. Okay, two voltage source. So meaning that you need to double check, okay, the elements, which element that absorb, which element that actually supplying. Okay, it doesn't necessary that you need to write down all the elements power. Okay, you just maybe write down the total, because the question is was just to just want you to calculate the total power supplied inside the circuit. So you need first, what you need to do is to get the direction of the current, the whether the element is supplying or absorbing. Okay, so can we look at the I1, the elements, the element of 5 ohms. So, okay, for the I1 that we already obtained is a positive values, right? I think positive values. Positive values. So, meaning that 5 ohm is actually absorbing. Okay, absorbing. It's not supplying. Okay.
Doctor,
Yeah.
isn't resistor only absorb?
Yes, yes. That's true. So that's why actually if you don't want to do that, it's okay, because actually all resistor are absorbing. So yes, you are correct. So if you don't have time, so you can just ignore the resistor. Okay, we are only concentrate on the sources. Okay. Okay, so can we just concentrate on the sources? Okay, so the resistor should actually should be absorbed lah. So no problem on that. I just want to clarify, just want to prove that actually all the resistor actually absorbing. The power is actually positive. Okay. So right now we are concentrating on the voltage source. So for the voltage source, you need to double confirm first, because some of the voltage source depend on the circuit is actually absorbing power. So we need to double check. So we go for 20 volt first. Okay, so the I4, the branch current that flowing inside 20 volt is actually positive, right? Positive, if not mistaken, is a positive 11 amperes. Meaning that the direction of the current that we assume is correct, which is the current is flowing from positive terminal. Okay, so the power is positive. Sorry, the power is negative. Okay, because the current is entering the negative terminal. So negative VI. So negative 20 multiplied with the current 11. So this one is negative. How much? 222. Is it? Mathematics ni. Yeah, 220. Sorry. Negative 202 watt. So it's actually supply, because you have negative value here. Okay. And then we check for the second voltage source. So the current that we assume, yes, is entering the negative terminal. So negative VI. Okay. So negative 6 volt. But the current I3, if not mistaken, is negative 5, right? So finally, the final answer is positive. So what is meant by positive? Meaning that this voltage source is not supplying, but it actually absorbing. So meaning that the answer for this question is only this. You just write down this. This one is not. Okay. So the total power supplied by the circuit is 220 watt. Okay.
Okay, doctor.
Okay. So next we go for the second questions. So the second question, this one is actually quite tough because actually that one is actually I modified uh, the question actually. So that's why sometimes when we modify it seems that it's a very difficult. Okay. Because that one, the original question is actually using mesh analysis, but I changed it into a nodal. So, but it seems to be very difficult. Okay, because some question we design, we need to make sure that the student can answer the question within the time frame. Okay, so that's why sometimes it's quite difficult. It's time consuming to design a question, especially for this electrical circuit. Hold on, I just want to share. So I need to check here. I think this one. Oh no. So it's not. It, hey, this one. No, no, no. Where is the? Oops, sorry. Oh, betul lah. This one Ohm's law. Where is it? Okay, this one. This circuit looks similar. So consider the circuit shown in figure Q2B. So this is one is actually from your final exam, the previous final exam. So using nodal analysis, determine the current I1 and I2. Is there anybody that have already done that? Done this question? So if you have done, maybe you can share with us your answer. Because my answer, I'm not very confident with my answer. Okay, just to double check with you all. So my answer for I1 is negative 41 and my I2 is 100 M. Sorry, 11 amperes. So negative 41 and my I2 is 11 amperes. So please double check whether you get the same answer. Okay. Okay, this one I will not discuss. So I just want you to try it, but I give you the guideline because this one is quite tricky. Especially when you want to identify the nodes. Okay. Just to also to remind you, also just to take note that for your test one, your what you call the second question, the nodal analysis, is also not very tough. It's not very difficult. It's a very straightforward questions. Okay. So just to give you the guideline, especially on the which node, okay, that you need to identify. So first of all is actually the reference. Okay, so the reference is usually we just put the ground, the bottom one. Okay, and then we identify the node voltage. So this one is V1. Okay, and this node also. But as you can see here, this branch don't have resistor, meaning that there is no voltage drop here. And the current that flow inside here is also 0 because there is no potential difference between this node and this node, because this node also is V1. The current is only flow when there is a different in terms of the node voltage. So if this one is 10 volt, this one is 2 volt, then the current will flow. Okay, but right now the node here is actually the same, so the current will not flow. Okay, the current here, if the question asks you what is the current, so definitely the current is 0 because there is no potential difference. So this one is actually a similar node. Okay, a single node here. So this one is your V1, and the other node is here, V2. Okay, only 2 nodes. Okay, then after that, you need to identify the direction of the current. That is the very most important part. Okay, so since the direction of I of this branch has been given, so you just follow. So this one is the direction of the current for this branch. This one also. This one no need to have direction of the current because the current here is 0. Okay, so next is this one and this one. So we have like this. So KCL at node V1. So right now we consider this one as a very big node here. Okay, so the current that flow, you need to identify the current that flow in and out from this node. So we have one current going into, I think only one. Okay, only one current. And the other current is this one and this one. Okay, one current go in and one current go out. Okay, so let's look at this current that going into the node. Oh, sorry, this one also got some current. Okay, this one also, sorry. We have, so this one we didn't identify kan. So this one tak apalah. We identify this one also is actually going into the node. So we have two current that going into and two current that going out. So that's why sometimes your equations is incorrect because you forgot to identify the current. For if you see, so I actually forgot to take this branch current. Right. So we have two branch current that go in and go out. So two in and two out. Okay. So we go for the first branch current here. So this branch current, as you can see, we have a voltage source in between. So I name this one as I2. Okay, this one is I2 because this one is I2. So the current is flowing from node 0 to V1. So I can write down my KVL 0 minus V1 is equals to, the current is going to the positive terminal. So I2 multiply with 10 ohm, negative 200 volt, okay, because it's entering the negative terminal. Okay, so this is my KVL. So my, okay, negative V1 is equals to I2 multiply with 10 ohms minus 200 volts. So I rearrange this. So my I2 is V, sorry, 200 minus V1 over, okay, this one is my I2. And this one, I think I just put I3. Okay, this is I1 and this one. So KCL at node V1 is I2 plus I3 is equals to I1 plus 50 amps. Okay, this is my KCL at node V1. Okay, there are two currents that going into the node and there are two current also that going out from the node, which is I1 and the current source, 50 amperes. Okay, so for my I2, just substitute this equation. So 200 minus V1, 10 ohm, plus I3. So your I3 is right now 0 minus V1 over 50 ohm. Right? Equals to I1. So I1 is V1 minus V2 over 20 ohm plus 50 amperes. I think 50 amperes given that, yeah. Okay. So you need to rearrange this, simplify you to get V1 and V2. Okay, equation that have a V1 and V2. So this is your, you need to simplify, okay? So this is my first equation. And you need another equation, which is from V2. Okay, sorry. So at node V2, as you can see, there are two current that going into and one current going out. Colorful today. So V1 minus V2. This one is for I1, okay? Over 20 plus the current source. And this one is equals to V2 minus 0 over 100 ohm. So this is my second equation. So you have two variables, two equation. So use calculator directly and then just write down your answer for V1 and V2. Okay. So after you obtain your V1 and V2, so the question is find I1. So we know that this one is actually V1, this one is V2. Sorry, this one is V1 also. This one is V2. Okay, so your I1 from here, you can see that I1 is actually after you obtain your value, okay, V1, just substitute the value of V1 and V2, okay, and divide it by the resistor. So you will obtain your I1. And to get your I2, so I2 using this equation, so 200 minus V1 over 10 ohm. So you should get the answer is negative 41 for I1 and I2 is positive 11 amperes. Okay. So screenshot this one. You can screenshot before and then please try and then please double confirm my answer. Okay. I think that's all for our class today. Is there any questions regarding this particular example?
Doctor,
Yes.
can I put my ground voltage at below the 200 volt?
Sorry, what do you mean?
The ground voltage,
The
the
ground
VO.
voltage. Oh, cannot.
Okay.
Because if you see at the bottom part here, this node has much branch connected. Because the one of the guideline of to identify the reference node, the node that has the most branches connected to it. If you use this one, it's okay, but this is not the maybe your calculation will become more complicated. Okay, so it's much easier because right now, as you can see, this is only connected 2 branch, but for this node we have 1, 2, 3 branch connected, so it's very suitable for this to be selected as a reference node rather than this one. But it's okay, no problem. Okay, but the guidelines say that the most, because if you here, so you will have more nodes. I think 3 nodes, not 2 nodes. 3 nodes because we have this one, 1, 2, and V3, right? You have 3 nodes, V1, V2, and V3. If you choose this one as your reference node, you only have 2 nodes only. That's what is mean by the guideline. Okay? Faham? You understand?
Understand. Thank you, doctor.
Okay.
Doctor, can I ask if my simultaneous equations is in the fraction form, is it acceptable?
Sorry, in a?
My simultaneous equations I arranged in the fraction form, something like the fractions at V1s plus the fractions V2 equal to...
Oh, okay. Okay, no problem. No problem.
Okay, thank you, doctor.
Because you need actually calculate. Okay, it's up to you lah. Because usually for calculator, the input should for me is better. Yeah, calculator dia akan ambil yang not fraction numbers kan. Tapi it's up to you because I will look at the answer first. If the answer is correct, then you got full marks. But if the answer is not correct, then I need to go your equation one by one to double check where is the maybe you did some wrong at there.
Okay, doctor.
Okay. Where is your semester break? Week 7 or week 8?
Week 8, Doctor.
Next week. Week 8.
Week 8.
Okay, so meaning that this one is week 6, right? So we
Yeah.
have another week next week. So and then you have a semester break. You enjoy your semester break. Because I also will enjoy my semester break, week 8. But usually during the semester break, the lecturers will have a lot of workshops and so on. But that's good lah because we are relieved from the class. So we attend our professional workshop and so on. Okay, if there is no other questions, then we can dismiss the class today. But please be reminded that after this, you need to watch the pre-recorded videos that I have already prepared. You can see at my YouTube playlist the last videos. Okay, that one is actually for the superposition theorem. Okay, because after this we go to superposition, and then a little bit on the what we call the source transformation, and then after that Thevenin and also Norton. So Thevenin and Norton theorem will be delivered by next week. Okay, next week, and also we continue after the semester break at week 9. So week 10 we will concentrate on the AC circuit. So AC circuit, same mesh analysis per will actually solve the same use the same method but using a complex number because AC has a complex numbers. Okay, so it's much more challenging. So it's better for you to have this background to be very solid. Okay, because after this week 10, the AC source, actually there will be I think no theory at all because it's actually the same. Okay, we just applied for the AC circuit. Okay, for that, thank you very much for your attention. So we dismiss this class. Okay, so
Doctor,
assalamualaikum. Yeah, okay.
for the superposition video, after 60 minutes, it is show the same screen now.
Is it? I see. Why okay lah. After 60 minutes
Yes.
Oh, I need to redo again lah. Okay lah, it's okay. I will need to redo again and then after that I will inform you. Thank you very much for your info. Thank you.
Okay, thank you, Doctor.
Okay. And the notes also I have already uploaded in the e-learning, so you can download the notes. Okay. Okay. Thank you very much.
Okay.
Okay.
Thank you, Doctor.
See you during the test 1. Okay. Okay. Bye. Assalamualaikum
Thank you,
and
Doctor.
have a very good day.
Thank you, Doctor.